In this tutorial, we'll be creating a scene with a warped infinite 3D grid. We'll be using RayTK version 0.13, so make sure you're using at least that version or a newer one. There's a download link in the description. There's also a link to download a project file with the completed scene. We're going to start, as usual, by dropping the toolkit docs that you downloaded from GitHub into the project, which we've added here. We're now going to create a RayMarch Render 3D, and to do that, we're going to use the Alt-R shortcut to open the palette, and then type RR3, or you can type RayMarch Render 3D. Add one of those. Now, if you see multiple pages of parameters here, then you are all set, and you can adjust the resolution and other settings like that. If you don't see multiple pages of parameters like this here, it's because there is a bug in the latest version of Touch Designer that hides parameter pages in certain cases. The workaround for that is to use a parameter comp instead of the built-in parameter panel in the network editor. So if we create a parameter comp and then drag this renderer onto it, switch on page names, and then switch off built-in. And if you open up the viewer, you now see that you get access to the different pages of parameters. I'm going to be using a resolution of 1000 by 1000, but feel free to change that to whatever you like. Now we're going to add an out top so we can see the output. You could also use a null if you want. Next, we're going to create a base comp named params. We're going to use this to keep all of the parameters that control the scene in one spot. Create a base comp here. Set the name to params, and then create a parameter chop. Drag this operator onto it, and then create a null chop at the end. We're going to call that param vowels. Now, I've set up some panels on the side here to make it a little bit easier to see things as we're going through this. One of them is going to be showing the parameters of this operator here, and the other one's going to be showing the output. You can set those up if you want, but they're not necessary for the scene. We're now going to set up the geometry of the scene using SDFs. The goal is to create a repeating grid structure. While there is a grid SDF operator, it currently only supports grids along 2 axes, so we're going to use a different approach. Now open the palette and create a box frame SDF. This will be the frame of each cell in the grid. I'm now going to connect the output of that up to the first input on our renderer. And we can now see that rendered in the preview panel here. Next, we're going to set up some parameters to more easily control the size of this. We're going to go to our params comp here. Open the Customize Component dialog, and we're going to add an XYZ style parameter. Call it spacing, and we're going to set the default for all 3 parts to 1.5. We are also going to create another parameter, the float style, named thickness. And we're going to set the maximum range on that to 0.1 and the default value to 0.02, and close the component editor. We've now got all of those parameters showing up here in this chop. We're now going to apply those values to the SDF operator. And to make things a little bit easier to see, I'm going to drag this chop over here. I'm going to select the box frame SDF operator and drag each of these 3 channels, the spacing channels, onto the size parameter here. We're also going to drag the thickness channel onto the parameter. Now, rather than just using this spacing as it is, we're really going to change these expressions to divide it by 2. And the reason we'll be doing this will become apparent later, but in short, it helps it line up with how we're going to be aligning things later on. We've now got the basic frame of an individual cell in the grid. We're now going to add a Modular 3D and insert that between the box frame and the renderer. Now, the initial settings here are causing some issues in the rendering, and that's because of differences, because the size of the cell and the range that we are repeating it over are not quite lined up properly. So to fix that, we're going to drag the 3 spacing channels onto the size here. And we can now see that it is repeating each of those cells along all 3 axes. And if you adjust the settings on the parameters here, the 2 will now remain aligned with each other, no matter what settings you use there. You can also try changing the thickness parameter to adjust the size of the frame around each cell. Now that we've got our grid repeating on all axes, I'm going to add some shapes to the corners of each cell to give it a little bit more of an interesting shape. To do that, we're going to start with a octahedron SDF. And you can connect that up to the renderer just to see what it looks like. It's this 8-sided shape that has a point along towards each axis. I'm going back to the Modular 3D. I'm going to create a combined stairs operator and connect both the box frame and the octahedron to it. And insert that before the Modular 3D. So the reason that we are not seeing anything in the output is because there is one of these octahedron SDF shapes that's in the center of each cell, and one of those is blocking the camera. If we move it to the side slightly, you can see there that it is positioned there. Currently, the octahedron is in the center of the cell, and what we want it to do is be on the corners. Now, to do that, we're going to create a copy of this Modular 3D, connect that between the octahedron SDF and the combined stairs operator. Right now, it's repeating things kind of in the same positions that this later one is repeating, so it doesn't look like it changed anything. To deal with that, we're going to adjust the shift parameter, which moves the input shape within the repeated cells. And what we want it to be is at exactly half the size. Now we already have a parameter here that has the exact expression that we need, so we're going to right-click Scale on the box frame SDF, choose Copy Parameter, go back to this Modular 3D, and then paste that onto Shift and use Paste Expressions. We've now got the shape placed in each corner, and we're getting some of that stair blending pattern. If you change the radius on the stairs down, you can see that it is combining those two shapes there. We're now going to create some parameters to control the octahedron and the combined stairs operator that we just created. I'm going to go back to this params comp, open customize component, and we're going to create a float parameter named corner radius. Move that to the bottom there, and set the default to 0.3. We're then going to create another float parameter named stair radius. And this is going to be for the distance that the stair blending applies between the two shapes. Now for this one, we're going to set the default to 0.15. We're going to create another parameter called stair count. For this one, we're going to set the maximum range to 10 and the default value to 6. Going back to our geometry over here, I'm going to select the octahedron SDF, I'm going to close this component editor, and drag the corner radius channel onto the octahedron SDF. Choose job reference. Now, as we adjust that in the parameters here, you can see that it is controlling the radius of those corner shapes. Then on the combined stairs operator, we're going to take the stair radius channel, drag that onto the radius parameter here, use job reference again, do the same thing for the stair count channel, and drag that onto the number parameter here. And you can now use the stair radius to control the size of the blending area between the two shapes, and you can use the stair count to control the number of steps within that blending area. And we're going to go back to the default setting for both of those parameters, and also for thickness. So what we have now is the infinite 3D grid with this box frame around the edges of each cell, and then these octahedron shapes copied onto each corner and blended with the stair blending. Next, we're going to create a twist operator. And insert that between the Modular 3D and the renderer. And we're going to set the axis to Z. If you adjust the amount setting here, you can see that it is twisting the whole grid along the same axis that the camera is looking down. Going to create some parameters to control this operator as well. Going back to our params, opening that, and adding a float parameter called twist. Move this down to the bottom. Going to set the range on this from negative 0.25 to positive 0.25, and then keep the default at 0. Closing that and going back to the geometry, going to drag that new channel, the twist channel, onto the amount parameter here. Now you can control the twist from the main parameter panel. Now that we've got the geometry set up for the scene, going to add some animation to it. So there are two parameters that we're going to be animating. And that is the offset parameter on the stairs. You change that, it gives it that infinitely expanding or contracting pattern. On the modular 3D, we're also going to be changing the shift Z so that we can move forward and backwards. Going back to the parameters comp, open customize, choose float, and then add a stair speed parameter. And a movement speed parameter. Moving both of those to the bottom and selecting both of them, we're going to set the range for both of them from -1 to +1 and leave the default at 0. Closing the component editor, going to go back to our geometry, and we're going to create a select chop, drag the parameter values chop onto it, and choose those two channels that we just created, stair speed and movement speed. We're going to add a rename to those to offset and TZ, or translate Z. So to add that animation behavior, we're going to create a speed chop, add it here, and then add a null on the end, and set the name to anim vals, or animation values. Next, we're going to select the combined stairs operator and drag the offset channel here onto the offset parameter. Then on the second modular 3D, we're going to select this TZ channel and drag it onto the Shift Z. Now, if you adjust the stair speed, you can get a smooth, continuous motion along each of those corners there. And if you adjust the movement speed, you can have it move forward and back. So we've got our geometry and animation set up, but we are still using the default material and the default lighting and the default camera. So we're now going to create a camera operator. I'm going to create a look at camera. Move that in here. And we're going to connect that to the second input on the renderer. We're also going to create a parameter to control the FOV angle here so that we can get more control over that view. So going back to our parameters comp, we're going to add another float parameter. Call this cam FOV. We're going to set the range from 0 to 150. Set the default to 90. Closing that. Now that we're working on the materials and lighting, I'm going to move this parameter values chop over here. Going to select the look at camera and then drag that new cam FOV channel into the FOV angle parameter there. So you can now control that from the parameter panel over here. Next, we're going to add a material. We're going to create one of the new modular materials. These operators are still in the beta status, so when you go looking for them in the palette, you need to make sure that this B filter toggle is switched on or they won't show up. Searching for modular mat. If you want to learn more about this modular material and the different options that are available for it, check out the materials tutorial which came out earlier on my channel. So connecting that between the twist and the renderer. Right now, all it's doing is using this flat base color for everything. We're going to change that to black because we don't need the base color at all. And we're going to add two different shading elements to this. So the first one is going to be a Diffuse Contrib, which does diffuse shading. So add that to the second input on the material there. And we're going to set the level on this to 0.45 and make sure the use color setting is switched on, and change the color here to kind of a light blue, so 0.55 and then 1, 1. We're going to choose the Oren-Nair shading method and set the roughness to 0.6 and the albedo to 0.8. Next, we're going to create a Specular Contrib, which provides kind of the highlight shading. So connecting that to the third input here, making sure the use color setting is switched on, and change the color to pale orange, like 1, 0.8, and 0.5. I'm going to choose the GGX shading method, set the roughness to 0.8, and the Fresnel will stay at 0.5. Next, we're going to set up the lighting. Create a point light operator. Connect it to the third input on the renderer. I'm going to set the position to 0.5, 0, and -2, and the intensity to 1.5. We're going to leave the color at white for now. Right now, the light is being applied at full brightness everywhere, except for the places that are being shadowed, but that can make the background here a little bit indistinct and hard to see. So we're going to switch on attenuation. So that will make the light at full brightness within a certain range of the point, and then fading out the further that it gets away. I'm going to set the attenuation start, so this is the size of the area that gets full brightness, to 3.5, and then the attenuation end to 6, and that's the area beyond that that gets kind of the darker shading. This is similar to what's the settings in the standard light comp. So right now, the attenuation is making the light at full brightness within the range and then fade to black outside. So next, we're going to change how the attenuation affects the color as well as the brightness. I'm going to create a color ramp field and connect that to the second input, or the attenuation field input on the light. Now we're going to get an error on this, and that's because when you're using fields with lights, you need to make sure to set the context type to light context. If you are using a version of the toolkit 0.14 or later, this will be automatic, so you won't see that parameter. So now that this is attached, inside the attenuation range, it's using this second color, and outside of it, it's using this first color instead of going to just black and full white. I'm going to set the first color here to kind of a dull bluish green, go 0.15, 0.25, and 0.3. Then we're going to set the second color to kind of a pale yellow, so 1, 0.9, and 0.7. So we've now got our geometry, our materials, our camera, our lighting, and our renderer set up. And we've collected all the parameters to control this in one spot on this parameters comp. And now that we are done editing things, we're going to move these chops back next to it. And if you adjust the parameters here, you can see that it responds instantly, which can be what you want. But if you are in a live performance setting, you typically don't want things to just snap immediately to whatever settings you changed it to. Now, to smooth things out, between the parameter comp here and the null, we're going to add a filter. So now, if you change the settings, it will smoothly transition to whatever the new value is, and you can adjust the filter width here to change the speed of that transition. So to recap, we are creating our geometry using a box frame SDF, combining that with an octahedron that's been shifted and repeated onto each corner of those box frames, combining those two using this combined stairs operator, and we're adding some animation to the offset that causes the motion along those blend areas. We're then feeding all of that into a modulo 3D, which is repeating that whole shape along all three axes. We're adding some animation to the Z shift parameter, which is causing it to kind of move continuously along the Z axis. Next, we're adding a twist that warps the whole grid along the same Z axis. Next, we are using a modular material where we've set the base color to 0, and then we're using these two shading elements, a diffuse contrib element with Oren-Nair shading, and a specular contrib using GGX. We're then using a point light with distance attenuation to make it darker outside of that attenuation range, and we're using this color ramp field to adjust how that attenuation range affects the color of the light. So instead of just affecting the brightness, it's also applying a little bit of a shift in the color from this kind of dark blue green to a pale yellow. And we're controlling all of that with parameters on this comp here and smoothing out changes to those using a filter chop. So I hope you enjoyed that. Make sure to like and subscribe to find out about more tutorials that are going to be coming out soon. And thanks for watching.